Today, we're going to learn how to traverse a binary tree using a B node. Hello, I'm James Helfrich. Traversing a linked list is very straightforward. There's only one way to go. From every node, just go to the next node by the P next pointer. Well, a binary tree is different because you have two options, the left node and the right node. So how do you traverse a binary tree? This video will explain 4 different methods to traverse a binary tree. The first method to traverse a binary tree is called LVR, or left visit right, otherwise known as in-order traversal. First, we take P left, then we visit our node, and then we go P right. So our algorithm is recursive. Our function we call display LVR, and we take the pointer to the head, and then we call recursive call on P head arrow P left, which is the left branch. Then we take a look at our current node, which is the visit, and then we take a look at our right one, which is P head arrow P right. So if I have these 9 nodes in a binary tree, I'll first visit A, and then B, then C, then D, then E, then F, and so on. Let's take a look at how that plays out. All right, so now I have a smaller binary tree, and I'm going to have the same algorithm here. I'm going to begin by calling display LVR with the D node as my head node. And then immediately, well, since it's not the null pointer, I'm going to call display LVR on P head arrow P left, which is going to be the B node. Now I have 2 elements on the call stack. I have the D call and the B call. Well, when I'm in the B, which now B is my P head, I'm going to immediately go left again. Now I'm going to call display LVR on the A node. Now, once again, I'm going to call P head arrow P left, and A does not have a P left, so I'm going to null out of that. Then I'm going to display A. And then I'm going to call display LVR on P head, which is A, arrow P right, and that has nothing. So then I'm going to finish with that, and I will return out of my display LVR A, which takes me back to B. Now, after I'm in my B call, I've already done my left branch, which was A. So now I'm going to visit myself and display that, and then I'll call my right branch, which is going to go to C. Now, C has no left child, then I'll display myself, and then it has no right child. So I'll return out of C, which will go back to B. Now I've completed all of B. I did left and visit and right. So now I'll return back up to D. Now on D, the left branch has been visited. So now I'll visit myself, and now I'll go right, which will go to F. Now, when I get to F, I first go left, which is going to be E. When I'm at E, first I go left, there's nothing there, then I visit myself, and then I go right, but E has no right child. So now E is finished, and I return back to F. Now F's left branch is finished, so now I visit myself, and I go to the right branch, which has none. Now the F is finished, so I'll go back to D, and now D is finished. And now I complete my algorithm. All right, another method to traverse a tree is called RVL, or backwards traversal. First, I'm going to go right, then I'll visit myself, and then left. And this will be exactly the opposite of what we did previously. All right, so let's walk through this. So I'm first going to call visit RVL on D, and that immediately takes me right. And then I will call it on F, and I'll go right, but there's nothing to the right. So then I'll visit myself and I'll display F. And then I will go left, and left will take me to E. So E, first I'll go right, but E has no right child. I'll display myself, and then I'll go left, and there's no left child there. So now E is finished, and I go back to F. Now F has already attempted to go right. There was nothing there. It already displayed itself, and then it finished all of left. So now F is finished, and I'll go back to D. Now D has already gone right because it did F and E. I'll visit myself, and then it's going to go left, which is going to call B. Now B initially is going to go right, and then gets to C. C is going to go right. There's nothing there. Then I'll visit myself, and then I will try to go left, but there's nothing there. So now C is finished, and I return back to B. Now B has already finished its right child, so I'll visit myself, and then I go left, which will go to A. Now A will try to go right. There's nothing there. I'll visit myself, and then I'll try to go left. There's nothing there. So A is finished. We go back to B. Now B is left and right is finished. So we'll go back to D, and then D is finished as well. The next traverse is called VLR, for visit left right. And this happens every time we need to do the node first before the children, such as when we copy a binary tree. So let's take a look at how this works. So I will first call it on D, and then I'm going to display myself. And so I'll display myself, and then I will go left to B. Now B will display itself, and then it will go left to A. Then A will display itself, and then it will attempt to go left, there's nothing there. It will attempt to go right, there's nothing there. Then I'll go back to B. Now B has already visited itself, it's already gone left, so now it will go right to C. Now C will display itself, then try to go left, nothing there. Try to go right, nothing there. Then it'll be finished. So go back to B. Now B has visited itself, it's gone left and right, so it's finished. So go back to D. D has visited itself, has gone left, so now we'll go right to F. F will visit itself, then it'll try to go left. Oh, there's something there. E will visit itself, try to go left, there's nothing there. Try to go right, there's nothing there. So now E is finished, go to F. Now F has visited itself, it's gone left, it'll attempt to go right, there's nothing there, so F is finished. And I go back to D, and D has visited itself, and it's gone left, and it's gone right, so it is finished as well. Another way to traverse a tree is LRV, okay? And it's called post-order traversal because I'm going to visit myself last. And this is really good when I want to delete a binary tree because I don't want to delete a note until after its children have been deleted first. All right, so I will start by starting with D, and I'm going to go left first. Then I'm at B, then I'll go left first. Then I'll go to A, I'll go left, there's nothing there. Then I'll go right, there's nothing there. Then I'll visit myself. Now A is finished, and I'll go back to B. B has gone left. Now it's going to go right, and we get to C. C will try to go left, can't. Try to go right, can't. Visit itself. Now C is done. It'll go back up to B. B has visited, it has gone left, and has gone right, but now it'll visit itself, which will display it, and now it's finished. Now D has gone left, but now it needs to go right. F needs to go left. E tries to go left, can't. Tries to go right, can't. So it'll visit itself. And then E is finished, so go back to F. F is left visited. There is no right visit, so now it'll visit itself. Now F is done. Now we go back to D. D is done a left. It's done a right. Now it'll visit itself. This was example 5.1 and 5.2 in the C++ data structures textbook.